So now for an explanation of how all my different subsystems work. So I'm using a pretty typical video screen. Obviously, any digital number can be made up of 7 bars, 3 horizontal, 4 vertical. These are the colons. These are all the different digits. This little weird formation here is the A and then the P for the PM. So I have those in separate things. Okay, so that's kind of not all that unique. I'm sure you've seen that before. So this is how I do my layout. What I do first is I get all of their different feeds into 7 lines. And I stack the lines like this. I know I've got everything really compact, so bear with me. So we've got the 1 line here, 2, 3, 4, 5, 6, 7. And then run the whole length of this part right here. And each digit has their own set of 7 lines. Now you'll notice some of the digits have shorter lines, and that's because they don't actually have as many memory blocks. Along this series of lines, there are columns, and each column has the data that is storing each of those different digits, because each of those different digits is just a different combination of those 7 original lines. And they're stored in each of these little columns here. You'll see this series of 7 switches here, 1, 2, 3, 4, 5, 6, 7, and all these gates here. That whole cluster there represents 1 memory block for a single digit in that placeholder. And to show you an example of how it works, I've made this little map here, so it's showing you what the digital thing looks like with the 7 different lines. Each line is therefore representative of a different position. So this is the top line, this is the top right, top left, middle, the bottom left, the bottom right, and the very bottom. So when we want to program a different digit, we simply have to turn the different ones on. So for the 0, we've got the top one on, the top left one, the top right one. The very middle one is turned off, and then I've got the bottom left, the bottom right, and the very bottom left turned on. When that digit becomes active, a signal comes through this column here, this twisting column, and activates all these pistons and exposes all of these different repeaters, which then send their signals down the lines and create the digit on the screen. Pretty straightforward. And so, of course, because some of the digits only have to go from 0 to 5, whereas other ones have to go from 0 to 9, you'll notice in this particular video core, some of the digits will be shorter and some will be longer. The 0 to 9, 0 to 5, 0 to 9, 0 to 5, the 0 to 9, or actually, sorry. Sorry, this is a 0 to 9. I have a simple 1 that gets turned on in 2 particular circumstances, right next to that last digit there. Alright, so that's the video memory core pretty much. This is what actually stores all the different digits. And the cool thing is too, because of the fact that it's not some sort of fixed position or drum fed or whatever, you can actually come back here and change these digits at any time you want to in different set of symbols. Obviously this is a lot bigger and more extravagant than a drum memory using like glass blocks and whatnot and doing that sort of thing, but I kind of liked it because, and like I said, it's a very modular design. It's easy to stack and expand and upgrade and whatnot. Alright, now, because we're on the topic of the video memory, before I go on to the next part, I'll note that because I have 2 separate memories, the alarm and the clock, I had to make 2 different gates. But I wanted to use the same video memory. I didn't want to just stack another video memory. And I needed a way to get 2 signals. Now, originally, before, these vertical stacks here were just using half slabs to save on space. But because half slabs only allow the signal to go up, I wanted the signal to be able to travel both up and down, because the distance between this repeater and this repeater is actually less than the 15 blocks. So I can actually send a positive signal either from the bottom or the top, which means I have essentially dual video functionality for these video cores. And so the bottom of the clock is where the actual clock memory is going into the different video cores, and then the alarm memory is on the top, feeding through the top. And if you'll notice too, these are the lines that are actually coming from the logic memory, which I'll explain next. But before they make it to the video memory, they come through this next set of gates here. And this is what actually switches it from alarm to clock. Right now, because we're viewing the clock memory, these are all turned off. If you go down here, these are all turned on. And that's why their signals are coming through and the alarm memories aren't. Okay, so I think we're actually going to back out of here for a second, real quick, because I actually have those example modules out here, which you probably saw at the beginning of the video, which will make the next part really easy to explain, because the logic memory cores are just really wrapped in cables and other stuff. It's kind of hard to see what's going on. So just a quick review again. Here's what an exposed video core looks like. This is another 0 to 9 series. These are all the 7 bars on the outside, bringing the signal along. Alright, so this is the actual logic memory. This is what lets each digit know what the heck it actually is at what time. And what I dubbed it, or what I named it, is the scrolling memory block. And the reason why I call it a scrolling memory block is because it only does two things. It'll scroll one direction or another. It does have a reset function, obviously, so I guess technically it has 3 functions, but primarily it only has 2 functions. Now, this particular design actually goes around in a loop, and the reason why I did that was because an earlier model I had, all of them were stacked right next to each other. Like there was the 0 digit, the 1 digit, the 2 digit, the 3 digit, all the way up to 9. And then the signal that it was sending from the 9 back to the 0, or the 0 back to the 9 if it was carrying the other direction, took longer than a second to travel, which made it kind of useless if I wanted to use it for a clock that was actually counting seconds. So instead what I decided to do was just loop it. I ended up taking the whole length of it, cutting it in half, and then taking that one half, flipping it 180 degrees, and schmucking them together, and getting this nice little unit. So now the signal will go, like as it's scrolling, it'll jump from block to block to block to block to block, and continue around in a circle. And all you have to do simply is, when you're taking the inputs from the lines laterally like this, you just simply have to stagger them. So basically what that means is, when you come to here, if you're looking at the individual blocks, like look at the double sets of gold blocks, imagine that's an individual block. So here's the 0 position, here's the 1 position, the 2, the 3, the 4, and coming back around to the 5, the 6, the 7. When those lines are coming up and out into the video core, because of their positions, I simply had to stagger them. So the video core isn't just 0 to 9, it's actually 0, then 9, then 1, then 8, then 2, then 7, etc., etc. But again, that's just having to do what you got to do to make your creation work, right? So anyways, alright, basically the best way to start is right here. So the 2 major functions are the up pulse and the down pulse. So if you remember before how I said that the counter, I'll actually show you where that is on the Command Manager just real quick. Too long ago. Now this is a lot to process at once. If you need to go back, please do it. I don't even know how I remember how I have this stuff is here myself. Okay, so this here is that particular gate I was talking about. It gates whether or not it's going to come through this line or this line, but it's taking that pulse from the timer. So it's going to be 1 second pulses coming down this line or this line, and they represent the up and down pulses. Now those 2 lines come down right here. And why this one? Because this one is where the actual magic happens. This is obviously the second position of the clock memory. So the very, like, not the 10 seconds, just the 1 second position of the clock memory. And so the up pulses are coming through this line, and the down pulses are coming through this line. And again, I have pulse formers here. Not because it's necessary when it's in clock mode, but it's definitely necessary if you're still going to be adjusting the clock as well. So we'll go back to the example logic memory. Alright, so we have our up pulses coming through here, our down pulses coming through here. So what are we going to do with that information? Alright, the only way the scrolling block works is if one of the memories are active. If all of them were turned off, and to show you what I mean, if I were to take this one, this is the active one right now because none of the other ones are giving a positive signal. This is where the outputs come out. If I were to break that, and why don't I have a pulse for it? Anyways, I'll just